friends, so today, as you know, we have been continuing with the lesson chemical reactions and equations. So today also we'll be continuing with the another topic of that lesson. So let us begin. So our today's very first topic is balancing a chemical equation. So complete the table aside on the basis of the equation 9. Equation 9 is given over here, and it was at the back also. So here, element Ag, number of atoms. First of all, I'll show you once the equation 9. So as you can see, this is the equation 9, and on the basis of this only we have to complete the table given over the next page. So we have to here put in the values of Ag, NO, NaCl means silver, nitrogen, oxygen, sodium, chlorine on the reactant side and on the product side. So this is only known as balancing, means when the number of atoms on the reactant side is equal to the number of atoms on the product side, we say that the chemical equation is balanced. Now it is seen that the number of atoms of the elements in the reactants in the equation is same as the number of those in the products. Such an equation is called as balanced equation. That's what I just told you. If the number of atoms each element is not same on the two sides of an equation, it is called an unbalanced equation. Means either it can be a balanced equation or it can be an unbalanced equation. There is no third party over here. Now let us move on. What we have to remember, that in any reaction the total mass of each elements in reactants is same as total mass of each of the respective elements in the products. This is in accordance with the law of conservation of mass that you studied in the previous standard. Means what they mean to say that the total mass of elements on the product side is equal to the total mass of elements on the reactant side, and this is taken from the law of conservation of mass which we had studied in the 9th standard. So now we'll see the steps in balancing a chemical reaction. So steps in balancing a chemical reaction include chemical equation is balanced by steps. Means there are formally 4 to 5 steps which we have to follow in order to balance a equation. A trial and error method is used for purpose. Consider the following equation as an example. Means this method which is given is known as a trial and error method. So the very first step is write the chemical equation from the given word equation. Means see, you either you will be given this or you will be given this. If you are given this word form, then you will have to convert it into this form, and then only you can balance it. So sodium hydroxide is nothing but NaOH, sulfuric acid is nothing but H2SO4, sodium sulfate is nothing but Na2SO4, and water is nothing but H2O. So we will now write it in the equation form. So we write it as NaOH plus H2SO4 gives Na2SO4 plus H2O. We'll remark it as equation 1, but over here it is the 10th equation in the whole lesson, so they have marked it as 10. So now second step, check whether the equation 10 is balanced or not by comparing the number of atoms of the various elements present on the two sides of the equation. Means this is the reactant side, this is the product side. We'll make a table of 3 blocks. First will contain element, second reactants, and third one products. So now there are how many elements of Na? 1. O 1 and 4, that is 5. H 1 and 2, that is 3, and S only 1. And now on the product side, Na 2, S 1, O 5, and H 2. So now here which equations are which elements are not equal? So that is Na and H. Here Na is 1 less on the reactant side and H is 1 more on the reactant side. So now we will have to balance it. Now third step, we'll move on to the third step, which is that it is convenient to start balancing an equation from the compound which contains the maximum number of atoms. Moreover, it is convenient to first consider the element in this compound which has unequal number of atoms on the two sides. Now we'll get to the conditions through which we can balance these equations. Means if we add means we have to balance Na. So what if we add another if we add 2 over here, so what will be its effect on oxygen and hydrogen? So O will also become 2, H will also become 2, so here there will be an increase. So that is only the properties or the characteristics which we have to put in our minds, so that the whole equation doesn't get balanced. We just balance the element which we want. So for that we have been given several steps in the third step only. So now we'll study them. It says that in the equation 10 there are two components, Na2SO4 and H2SO4, which contain the maximum number, that is 7 atoms each. Both contain 7 atoms. Now you will ask how. This 2, this 4, 6 plus 1 of S. This 2, this 4, 6 plus 1 of S. Okay, so select the compound Na2SO4. Select sodium for balancing, as the number of atoms on sodium in this compound is unequal on two sides. Means here 2 atoms, here just a single atom. So it is unbalanced, so we'll need to balance it up. So it should be remembered that the formula of compound cannot be changed while balancing the number of atoms. So it is very important that the formula of compound we cannot change while balancing it. It means that here make the number sodium atoms in reactants as 2. So we'll write a 2 over here. So NaOH cannot be changed to Na2OH. As you can see, this 2 will not be added over here. It will be added in the front. Instead, a factor will have to be applied on NaOH. Writing down the result equation on doing this, we'll get the equation as this. I'll zoom it up so that you can see this. So see this. Now 2 we have added over here instead of here. So now check whether the equation again. So one more thing I would like to tell you, that if you are balancing the equation on every step, you will have to check whether the equation is getting balanced or not. It is very necessary. So now check whether the equation is balanced or not. We find that the equation is not balanced, as the number of oxygen and hydrogen atoms are unequal. Now what you saw when you applied 2 over here, so it became 2Na, but the value of O also became 2. First it was 1, now it became 2, so there was an increase. So from 5 it became 6. So now O also became unbalanced. The value of H also increased. It was 1 first, now it became 2H. See, if you will put the number over here, it will affect the whole equation, means whole sum. This which is given, it will affect this whole, not this one, just this one. So it will become 2Na, 2O plus 4, 6O, and 2H plus 2, 4H, and S 1. Now the whole equation is unbalanced, now leaving S. So now what we'll do is apply a factor 2 on the product H2O. Now we'll apply a 2 over here, as we know that H and 2 are only unbalanced and Na and S are balanced, so we'll not touch them. We'll just see a place where just H and O are present. So here in H2O, H and O both are present, so we'll apply a 2 over here. So now what it will become, 2 2s are 4H2O, 4 hydrogen, so hydrogen balanced, plus 2, now this O is 1, 1 2s are 2, so O also became 2. So 5 plus 1, it became 6. How O twice O plus 4 times O, it becomes 6 times O, and so it will be equal. The reactants and the product side will become equal. Now we'll write down the final balanced equation. So friends, that is it for today. Today we learned the process to balance the equation and how can we get helped with the textbook only in order to balance the equation. Many students find it very difficult to balance the equation, but I would like to tell you that it is very easy once you read the textbook. That's only my recommendation, is that you first just read your textbook. So friends, that is it for today. Just like the video, share with your family and friends, and also subscribe to our channel. You can put in your question down below in the comment box so that we can help you out with the problem. So friends, thanks for watching, and bye bye.